Sir, good afternoon, sir. Sir, Nagashika, sir. Sir, now you can give the welcome speech. Sir, please unmute your mic, sir. Thank you, sir.
Good afternoon. With God's almighty blessings and our Honorable Founder Chairman's blessing, I am delighted to start this event. I am Dr. P. Nagasangar, Professor and Head, Department of Mechanical Engineering, SA Engineering College, delivering this welcome address. On behalf of SA Engineering College, our Honorable Chairman, sir, our Honorable Secretary, sir, our Honorable Correspondent, sir, beloved Principal, sir, HODs, the faculty members and students, I cordially welcome our guest, Mr. P. Kumaravel, Senior Design Engineer at TANCAM, to this event. Thank you very much for accepting our invitation, sir. Thank you. On behalf of Department of Mechanical Engineering, faculty members and the students, I wholeheartedly welcome our new students to this department. Now, I would like to introduce about our chief guest. Mr. P. Kumaravel is going to give topic Design for Sustainability, Bridging the Theoretical Concept with the Real World Application. Mr. P. Kumaravel is an outstanding mechanical engineering professional with over 12 years of experience in engineering education, manufacturing, industrial consultancy. He is currently serving as a senior design engineer at Tamil Nadu Center of Excellence for Advanced Manufacturing. His expertise lies in digital manufacturing, industrial automation, sustainable manufacturing practices, and advanced engineering tools such as CATIA, robotic programming, and product lifecycle management. Mr. Kumaravel has actively contributed to technical training, industrial academy collaboration, and the promotion of Industry 4.0 technologies. He is passionate about innovation, energy efficiency, and a smart industrial system, inspiring young engineers through his knowledge and professional experience. Thank you, sir. Now I hand over this session to Mr. Kumaravel. Please, sir.
Thank you, sir. Thank you for your session. And so, may I audible?
Yes, sir. Yes, sir.
So, good afternoon to all present here. So, myself, Kumaravel, Senior Design Engineer from TANCAM. So, already I gave a quick introduction about myself. So, before going to this talk, uh, I hope all have understand my language. If you are feel any difficulties, you can mention. I will be go with bilingual like Tamil and English, or else I will be go with the English language. Okay. So if it is fine with you, I can speak. Okay, fine. So why I have chosen this topic for this presentation, design for sustainability. So what is this? As a first year student, as a joining new joiner after completing your 12th, you have to join engineering courses. It is common for all. What I have mentioned is. So what is in your mind? I'm going to join an engineering. I will become an engineering profession. Okay, right? So what the engineering professions needed in our current industry means you have to cope up with that ongoing global sustainability. That means if you have to create a new thing means it has to withstand for a long time. So if I am a designer or a scientist, I have to design anything new. It has to withstand for a long period of time or a prolonged period of time. Because if I am designing or found out anything within a period of next 6 months, another one product overtake this means it cannot withstand in a market. Okay? So we have to have a sustainable nature of things we have to develop so that it will be in a long run. So that's the thing I will be explaining it to you here. So design for sustainability means that means you have to as an engineer, as you are going to become an engineer means will be in your mind that we are going to create a new real world that is things we have to design. So how sustainably we have to create? Because if I create a component, for example, I will be creating some mobile phone. Means it has a lot of future in it, right? If my mobile phone future is not cope up with that customer needs or it is not able to sustain for a period of time, it cannot able to proceed with this. So the production, what we have made and what is the time we are spending in creating that model, everything will be of a rest of things. So that is the thing that will be happen when you are going for an engineering. So industries needed a person with high long, that means prolonged thinking knowledge they will be needing. So that will be I'm giving here design for sustainability, bridging theoretical concept with real world application in modern engineering. So why this title? Again, I'll be giving this question. Why this title here? Because you have a thought as a young minds, you are going to start your engineering career. So you'll be having a thought. So lot of new ideas will be get. For example, in your household itself. So for your mom is spending a lot of time in thinking. You are planning to make this thing shorter. So I am planning to uh, make something easier for example, for utensil cleaning. So cleaning machineries will be already there. Even though I'll be make it as a simpler form, you'll be having ideas. But if you are having an idea, you are going to produce the component means it will be taking lot of material like this. So if you are creating that component, once you have created, but it is not working. So you are wasting a lot of time, a lot of material, a lot of cost. What we are going to do means we are going to design a sustainable thing. That means we will be having a theoretical concept in our mind and we will be convert them into a real world thing through design. So we are going to provide a design for initial stage. Once the design is okay and everything is fine, then only we can proceed with the real world production system. That is the thing we are going to do here. Like civil architecture business. What we are going to do, if we are going to build a building, what we are going to do? So first we have to create a plan. So based on that plan, we'll be creating infrastructure designs, everything. So once the designs will be okay and it will be fine for everything means, then only we have to go for your production process, right? right? That means construction process will be started. Like this, we'll be starting here the design process, right? So see here. So what is this design for sustainability? Again, I'll be given. So when you are going for a design for sustainability, we'll be following three things. First one is environmental consideration, social consideration, and economic considerations. So what is that environmental consideration means? So it will not affect our environment. That is the first thing. I'm creating something, I'm creating an engine system or something, it will not pollute. So if you are going to buy a bike or something vehicle for your father or someone, you can see that they will be putting BS6 norms in that database, right? So if the vehicle is not crossing the BS6 database, we are not going to use that vehicle no more, right? Why? It will affect our environment to a higher level. So if we are going for BS6, the emission standards will be very low, so it will not affect our environment. So that it will be following the environmental considerations in anything we are planning. So if you are planning to start an industry in Tamil Nadu means, so once we are going for approval, that in that approval, pollution approval is also must. If the pollution board will not, if not approving your proposal means, then you are not able to start the company because it will affect the environment. Then the social consideration. Okay, so what the product produce, it should be beneficial to our society or other people. For example, if there is a manufacturing plant in our country means, uh, they will be having export. But even though, what is their local possibility for that product? They will be considered for before starting that company. Because every product manufacturing will be exported, then what is the use of it? So you have to familiarize with that. What is that social usefulness for that product? So that is the second thing. And then the economic considerations. So when we go for economic considerations, that means it should be financially stable. That what we have produced should be financially good enough so that we can produce a company. So as an engineer, you are going to start as an engineer, especially for a mechanical engineers. So these are all the things in your mind. If you are going to produce a component, after completing your engineering, if you are going to join in any of the company, what they needed is this. So what is your social consideration? So how it will be beneficial for the people outside, and how economically you can produce this. So this is the thing in your mind. So you have to know all these things. So see in that, this is the main thing you have to follow. Next, we have to have in three bottom lines. That means resource scarcity mitigations and regulatory compliance, consumer demand, and ethical products. So when you are going for a manufacturing, so these are all the things they will be thinking of. So what is the resource scarcity mitigation? That means what are all the available resources? For example, if you are using a petrol or diesel now, right? So what is the resource capacity? It will be withstand for next 50 years or 60 years. Apart from this, it is not able to get a resource for a long period of time. Do you know about yesterday's last week news will be go through? So due to the scarcity of petrol and diesel and increase in petrol and diesel costs, the Indian government has announced that we can going to use 100% ethanol fueled vehicles, right? So that is the thing government has started a initiative. That means we are not going to depend on foreign countries for petrol and diesel. So we will be producing ethanol from sugarcane extract, right? So that will be used. Already it will be used for 5% to 20%, but they are planning to use it for 100%. Now itself, they will be implemented around 80% in some of these petrol industries, right? So if you are going for 100% ethanol, we will be not depending on. So the resources scarcity that will be happened will be overtaken by another one methodology. That is the thing we have to think of it. And regulatory compliance. So what is the carbon mitigation rate? And like this, we have to find out. And the consumer demands. So what is the demand needed? For example, again, I will be going for petrol and diesel. So every day, there is a high demand in petrol and diesel. So instead of petrol and diesel, if we have to replace ethanol means, so the demand will be reduced further because instead of exporting or importing, we are using the ethanol which will be produced here itself, so that the people that will be getting affordable rate also. We are going to nowadays the petrol days will be reaching near 110 rupees. But when you are going for ethanol means it will be around 80 rupees or 70 rupees means it will be much better for everybody, as well as it will be consumer dependent, right? So these are all the considerations when you are going for it. Okay. So what is the frameworks we have to follow? So this is the main thing. So life cycle, eco efficiency. Yeah. So life cycle, eco efficiency, and social equity. So these are all the things we have to mainly follow. Okay. So analyzing the environmental impact of the product, right? So that is the main thing. And eco efficiency means that means with the fewer resources we have to create that system. So there will be less wastages. We have to consider this, and the social equity, ensuring and design consider parallels. Okay, so these are all the things we have to follow, right? Okay, so for this again we have to come to this circular design philosophy. So what this circular design philosophy means? See here, we have two phenomena. That means a linear economy and a circular economy will be there. Mostly we are switching towards the circular economy. So that is the thing. Because why? If you are buying something, for example, if you are buying some water bottle means, we have to take, buy a water bottle, use it, and throw it in a dustbin. And the water bottle is a thin material and it cannot be recyclable. So it will create a lot of waste to our environment. So that is the linear economical drawbacks. So when we are going for a circular economy, we can generate a material, that means regenerate a material. We can product life cycle extension will be there, and the resource recovery will be had. So see here in design. Yeah. So in this design, you will be see this in a circular economy. You can design, produce a component, retail, sell it, consume it, and reuse or repair it, and will be collected, test, and recycle the process, and again will be using, so that the raw material requirement will be reduced here. So that's why we are going for a circular design philosophy. So while on producing a component, if you have a potential for circular economy, you'll be having a lot of market balance. So if you are going for a plastic product like, you'll be getting approval is very difficult for us today, because it create a lot of waste to our environment. If you have go for a biodegradable waste or recyclable products means, it will be having a much marketing potentials, and we will be having a sustainable product. So while we are going for a production or going for a design, we have to think of it is recyclable. I will be in a circular economy or not. So that's the main thing we have to follow, right? So then, okay, so design for serviceability. So what is that serviceability means? It should be easily serviceable. That means if you are buying a bike, so if we not get spares regularly, if we are not able to repair the vehicle means, it is a drawback for the company. We will be not going for that. For example, in a Ola electric, what will be happening? So the continuous problems will be arising, and that shortage of service centers will be there. That will be create the loss of their reputations, and their product will be shortfall, right? Right? If you are going for example, Maruti Suzuki model cars, right? So it will be having lot of representatives, and spares will be available easily. That's the thing. The production and the sales will be higher. So if you are going for design and serviceability means, so easily repairable product should be, and upgradability. So it should be easily upgraded from one version to another. For example, in a petrol engine, we can add a CNG, or in a diesel, we add a CNG. Like this, it should be easily upgradable, and the resource efficiency means lower part, reduce supply chain complexity. So we have to reduce what is the requirement and what is the supply chain. So like this, as an engineers, we have to think of this. So what is the first thing we have to think of it? So we have to think of, it should be in a circular economy. you can regenerate it or not. What is the second thing we have to? It should have a easy repair parts we have to find out, and we can easily upgrade it. And the resource efficiency, we should have a supply chain. So there will be no shortage of any supplies, right? So these are all the main thing for design for serviceability. Okay, then we are going for these weight reduction methods. Why we have to mention it as A means nowadays A will be in all the fields, even in our design field also we are using AI. For analysis, we will be giving all the inputs and measuring it and find out the analysis. Nowadays, we'll be giving some of the input drawings. Based on the reference, they will be find out what are all the corrections that will be needed. So here, it will be mentioned as a topological optimization. So we'll be using a computational algorithm to place material only where it is structurally required, right? See here, what we are doing, there is a shaft and there is a two rollers here. Here, to connect, and at the bottom there is a two rollers and the side two rollers will be there. We have to connect these rollers with this shaft so that it will be sliding along this roller, this shaft. That is the thing we are going to do. For this, on initial stage, what we are going to do means, here there is a shape like this, some rod-like shape will be here, and it will be connected with all the rollers and it will be connected. If you are placing a rod-like thing here, it will be having a much higher weight, right? So the weight of the component will be higher, so that it will be creating lot of weight-related tasks, right? So see here, what I'm doing here, instead of rod, I will be creating a simple line-like structure, and we will be having a support inside it, so that it will also provide the same support, but with lesser material. So inside there is a gap. So why we have to go with this shape? We have to reduce that material. See here, lot of material will be reduced. Instead of fixing a shaft, we will be reducing the material and provide a gap inside. So what will be happen? So up to 60% mass reduction in aerospace bracket without loss of structural integrity. So we'll be reducing the material here. We'll be reduce the material quantity by around 60%. Based on this, we'll be having a structural integrity will not be disturbed, as well as we'll be using a lesser material. So when you are going for a lesser material, lower part obviously reduce supply chain complexity, right? So we'll be reduce the usage of material here. So the material requirement will also be reduced. So that is the thing we are going for this weight reduction system. So weight reduction is one of the sustainable manufacturing. So while you are going for purchasing a chair, the previous time it is a plastic motor chair. Nowadays, it is a hollow shafted chair. That means inside there will be a hollow and support will be provided. It will be also providing the same rigidness that last plastic chair provided, but it will be very less weight compared to this. So like this, it will be going for our production system, right? So what will be happen when you are reducing the weight to percentage? So what we are reducing the weight reductions by 10%. It will be equivalent to fuel reductions up to 7%, right? So that means we will be reducing the weight that will be impact on that environmental production. That means the fuel usages will be also reduced. That means that production life cycle will also be increased. So that means we will be having a low cost efficiency that we can produce more component in the case of a fuel compounds. That's the thing that will be happening, right? So, okay, next we'll be going for this. So we'll be having a topic of design for sustainability. So sustainable productions, the major two technologies I will be mentioned here. One is additive manufacturing and another one is digital twins I will be mentioned here, right? So what is this additive manufacturing and digital twins? So additive manufacturing. So additive manufacturing is we are going for making the material as a deposit. Instead of getting a raw material and machine it and manufacturing it, we are going to deposit a material and we have to create it. So this additive manufacturing is also named as 3D printing technologies. We are mostly coined with the name 3D printing technologies. So apart from this, some of that terms will be used, but mostly we'll be using as 3D printing technologies for additive manufacturing. Okay. So what is the main theme of this means? If you are using a 3D printing, you have to know about a 3D printer, 3D printing technologies, what we are using. So lot of 3D printing components. For example, even a small toys to a larger component also there will be a 3D printing here. You will be see lot of videos in YouTube for 3D printing. So what is the benefits of 3D printing means? If you are going for a 3D printing, we can print a component, right? So we can print a component a layer by layer, so that the inner part will be hollow and we will be providing the support, right? So we can create a shape what we are needed, but with lesser material. What much less means it will be around 90% compared to the subractive. So what is the subractive method? If you are taking wood and carving it to a statue, that is called a subractive method, because the wood is a hard solid material. We are using a tool to carving each and every part of the wood and make it as a statue, right? So the carved material will be the wastage and will be thrown. So that is the method we are using in a subractive method. In additive manufacturing, we are going to manufacture the same statue, but we are not going to carve the material. We are using the powder material and melt the material and make it as a layer by layer as per the shape needed, and then finalize the component for the statue. Okay, so this is the two things. So in additive manufacturing, there will be no wastages, and the inner will be there is a hollow part. We will be providing the support itself. But in that subractive method, hard material is carved so that a lot of wastages will be there, and the inner will be of solid surfaces. So there will be no that means higher material will be used, right? So that we will be going for this additive manufacturing. It will be provide around 90% of the material reductions. So that is the first sustainable methods I will be proposed here. And then second one is digital twins. So digital twins or digital manufacturing. What is this digital twin? Okay. So when we are going for a production, so as an engineers, we are going for industry, we have to start a company, or we are working in a company means we have to analyze what are all the equipments there, right? So what are all the equipments, what are all the production processes that will be taking place there, and then what we are going to do in this. Okay, so we have to plan everything, and then we will be starting our work. Okay, so when we are in as an engineer in a company, you will be promoted to a supervisor or a manager level. You will be giving some inputs. So what are the inputs they will be needed? So what is the optimization you will be doing energy consumption? For example, for a plant, they will be pay monthly 10 lakh electricity bill. So if you have reduced that electricity bill by 1 lakh per month, that means 10 lakh will be reduced to 9 lakh means they will be getting a profit of 1 lakh per month. So they will be given you additional pay of 30,000. That is much easy for them because you are reducing their burden by 1 lakh rupees. So that is the main thing. So what is the optimization of energy can do? You have to give the suggestions to them. Like so if you are an engineer, if you are giving any value added information or value added suggestions to a company, they will be giving you lot of answers. So that's why in the industry, some of the fresher will be get a higher salary comparing to the experienced one, because they will be giving some of the useful thoughts to the company. So that's will be pay them more, right? So like this, why we are giving this digital twin here means for analyzing this. So I'll be saying this, we'll be having a company. So in this, what we are going to do, we have to reduce the efficiency. That means we'll be improve that energy efficiency means we have to analyze what will be happen and what everything will be happen, right? So instead of going to the plant and working on it, as a student, how you are going to analyze means, or as a industrial person, how they will be analyzed means, they can create a virtual plant simulation. So I'll be creating a overall plant in a virtual mode. That is the design we are going to do. So that is called as a digital manufacturing. In my profile, Sari has informed that I will be expertise in digital manufacturing, right? So that will be comes under this. Digital manufacturing is we are going to create a whole factory setup in a digital environment. Its virtual plant will be created, and what is the working and how it will be working. Everything will be given here as an input, and we will be find out where are all the improvements will be there needed, and where are all we have to give any suggestions, and all that the equipment should be modified. Everything will be given here. Based on that only, we can go for the operations, right? So this is the thing that will be happen here. So this will be providing a lot of information to us, right? So I'll be going with some of the small demo related to this digital manufacturing, that is digital twin. See here, this is one factory setup I'll be shown here. So this is the thing created by us. See here, this is a factory setup. So see here, there will be lot of machineries will be there. See, I'll be zooming some part. Yeah. So there is lot of machineries will be here. So I'll be arrange everything here, right? So instead of going for a plan and find out how it will be working, I'll be creating a working environment here. And based on this, I'll be optimizing. See here. So this is the one unit. In this unit, there is a working table and the 3 employees are working here. The raw material is placed here and they will be inspected and send it out. And there is a conveyor system is there. They will be moving into the pallet. And there is a vehicle. That means it is called as AGV, automatic guided vehicles will be given. And it will be flowing through the path. I will be providing the path in which it has to be flow. So see here, I will be providing the path in which the AGV is flow. So it will be taking the component what will be produced here and it will be delivered here, right? Similarly, there is another plant here. See here, there is another working area here. They are also producing some other component and here also one AGV is fixed and it will be transfer the component to here and to this place. So I will be transferring all the component to this place. This is the main workstation. So there is a conveyor. For example, if you are seeing Coke bottle manufacturing plant, it will be automated. If you think of it like, so for example, car assembly unit. Here there will be producing one component, here there will be producing one component. And each component will be transferred to this plant and it will be transferred to the conveyor here. Okay, so it will be transferred. Here there is a lot of employees will be here. They will be assembled all the component in this line. After producing all the component, they will be dispatched the component to that exit area, right? So like this, so they will be providing a lot of sub-unit will be assembled and the final assembly will be happened. So while on working on this, we can find out where are all optimization is needed and where are all errors will be happening. So we can optimize everything. Okay, so these are all the plant structures. We can optimize everything. So if any error or corrections needed, we can correct everything. So that will be happen here, right? So see here, I'll be showing you. Yes. So see here. So here there is some of the working stations will be mentioned. Each person will be worked on their work. So if you have found out, for example, here there are around 5 persons are standing there, but for this work, these much of resources is not needed. We have to find out based on their calculation because it is that we are called this as a smart manufacturing or digital manufacturing system. We will be simulate how the humans will be working, how the human taking a component from one place to another and find out everything here. So based on this, we'll be given the input that so this person is not needed here. He is excess person there. And the process flow here, I will be mentioned that the AGV movement here. So I'll be mentioning it moving like this means here that bend take a lot of time. So it is not needed. We can make it as a staging. So it will be a time saving. Or else if there is any equipment here, so machineries are there means we can bend it and fix it. So for based on that equipment or based on that sustainability, we will be providing solutions for how we have to change the system. So that is comes under a digital twin. So we have to create a virtual plant and simulate everything what will be happen in the factory itself in a digital virtual environment in a system itself. Once it will be confirmed that everything will be okay, then we will be going for a production. So there will be no error happen, materials will be reduced, human labor requirement will be reduced, and the process will be synchronized properly. So these are the things we will be doing it in a sustainable production. So I will be suggesting that additive manufacturing digital twins. Apart from this, lot of technologies will be there. So we can go for additive manufacturing. Other than this, we'll be going for that robotic welding systems are there. The robotic programming, that means robotic automations will be there, and the CNC programming will be there. CNC machining will be optimized further. Like this, a lot of things will be happening. Like and apart from this, I'll be giving you another one important thing also. Nowadays, in mechanical industries, there will be equal opportunity for both male and female candidates. In the past, there is a thought that mechanicals is mostly for that means males only. It is not suitable for a female. But nowadays, in industries, most preferably for a quality inspection and for a design, like what we are doing, design related industries, there is a lot of opportunities for a female candidates. So for a quality inspection, around 80 to 90% female candidates are placed. And for a design industries, around 50 to 60% of female candidates are placed. So when you are going for a government jobs also, if it is a female candidates, they'll be having a higher priority compared to the female candidates. So for a mechanical, it is a betterment for both male and female candidates to take these opportunities, right? Then, so what is that? I'll be mentioning the bridging theories and practices. So what is that happen? So in a theoretical, okay, so dematerialization. That means what is the dematerialization? If you're creating a mobile phone, so already that mobile phone is weighing around some 50 to 60 grams. If you are thinking of reducing that material to 30 grams or 40 grams, okay, so what we are going to do, so we have to reduce the material. So wherever it is needed, we have to find it. So what we are going to do, we will be generative designs. That means we will be creating a shape, outer shape design we will be creating. Once the shape design is created, we have to find out where are all that weight reductions will be taking place, where are unnecessary parts or unnecessary platings will be there. For example, in a back panel, there is a covering will be there, one plastic plate. It's around 15 grams. We'll be make it as a mesh. Our mesh plate will be around 5 grams only. So we can reduce the weight by 10 grams. So like this, we'll be reduce each and every weight reductions so that we can produce a weight reduced material. So what is the impact? It will be produced around 35% of material reductions will be there. Cost reduction will be happen, and the material requirement will be also reduced. Previously, for a mobile phone manufacturing, the plastic panels, what are needed, they'll be using a lot of material limits. So it will be reduced around 35% limits. How much cost saving you can have to think of? Because for each day they will be produced around, for example, they will be using around 1 ton of material. Now it will be reduced to 650 kg weights. So the 350 kgs of weight and the cost and the labors, everything will be reduced. So that is the main thing for dematerialization. And carbon durability means, so we will be going for 3D printing technologies. So in a 3D printing technologies, the waste productions will be reduced. For example, if you are doing a wood carving, so you'll be carve the wood and make a statue. That carved waste will be sent for a fueling. That means we'll be burnt it and make it or something, right? So that will be creating a carbon durability. Okay, so that will be creating a carbon productions. Carbon footprint will be cast. So when you are going for a 3D printing, next additive manufacturing, 3D printing will be going with, will be directly melt and print a component. So no wastage will be formed. So that no carbon footprint will be formed. So it will be reduced by 50%. It will be mentioned. If you are effectively doing it, we can reduce your carbon footprint by around 80%. That is the possibility in this scheme, right? So when what is the future horizons? Will be mentioned here, smart materials. So we'll be making lot of materials. In road system also, in foreign countries, some of the methods they will be using. They will be providing a bottom fibrous material there below the road surface. What will be happen? Once the rain will be there, so that all the water will be sucked inside the ground system, right? So like this, we'll be going for a self-healing polymers or bio-based composites. So what is the self-healing polymers? So it will be regain its shapes once it will be returned to its original position, right? So that will be the smart materials when you are thinking of, and the product and services. Okay, so we'll be having a better servicing, product and service systems for each and every component. It will be easily serviceable. Then it will be easy for us. And AI is sustainability means. So nowadays AI play a major role in all the fields. For all the software industries, they will be using AI for testing everything, right? So it will also have an impact on mechanical industries as well as some other industries. When you are going for AI, see here in CAD modeling, that means what's the design I will be showing earlier. So previously what we are doing, we will be creating each and every component of the row. After creating the component, we are going for assembly, assemble it, and we can simulate it, everything we will be doing on their own. So it will be take a lot of time. So we are now we are having an AI system. So we'll be monitoring or integrating our CAD platform with the AI system. Then what happened? If you are giving an instruction, I need a change on the top surface with the doom of height 5 mm. I'll be given a prompt like this in AI. It will be integrated with the CAD. So for doom creation, what is the tool required? And for 5 mm, what is the thing they will be doing? And what is the endpoint they have to select? That all will be performed on their own. They will be selected and created. If any correction is needed, that only we can go into correct. So we are giving a prompt and create an object means it is much easier already for one product design and creation. It will be take around, for example, it will be take around for 10 days or something means. Using AI prompt, we can create a base structure on a 1 day and we'll be working on it and we'll be producing component within 5 days, right? So it will be reduce our working time to a much small, better extent. Okay, so these are all the things we'll be having a better advantages. Okay, so I will be completing with this topics and I will be giving some more information about this. What are the things means? So while I'm studying these things, so some of them think, so mechanical, they will be going for a production system, everything. That will be happen, but with this smart designing systems or sustainable designing systems, what will be happen? We can design everything, each and everything what we are needed in a proper manner. That will be in a proper success. Will be creating everything, and we will be given an input. So how it will be produced and how the input will be happen and what are all the procedures we have to follow. Everything will be given, and we have to produce everything. That means we will be in the production system. It consists of robotic simulations will be there, and then machining simulations will be there, and here the automation systems will be there, and even AR, VR, that means virtual reality will be also provided nowadays in a production system, right? So we are integrating everything in this system means we'll be having a better future on this field. So that's what I'm saying this. If you are going for a mechanical or some the core branches means you have to learn about these smart technologies, how we have to smartly working on it, and what is the future needed, and how we have to use that means. If you are knowing all this, you will be having a better options to working on. See this, I'll be showing this. I'll be showing another one. Just have a look at this. So these are some of the components I'll be produced using this software platform. So you open a component designs. So see here, I'll be having all the machineries here. That means I'll be providing a rack, and there is a machineries here. There is a one machineries there, and here there is one machineries there, and I'll be having a conveyor system, and rack will be there. Okay, so if you are producing a component here, we will be using this as a operational system. See how that sustainable system, that is virtual twin is working. I'll be giving a small demo on this. We'll be looking on it. It will be very helpful for you to understand what is the advanced technology that we'll be following here. You can easily able to understand. See here, this is one of the system. Okay, I'll be having all the machineries here. So I'm going to give some product to here. So I'll be adding some zone here. See. So I'll be adding something. So if you're working on it, it will be this. So I'll be adding one component here and I'm moving that component from here to this rack. So I'll be moving this component to this rack, and this in this rack, I'll be making it as a buffer. So see here, it will be moved to the rack, and I will be create a buffer here. See here. So I'll be selecting and making it as a buffer. That means we will be going to load the component in the rack. So it will be loaded with some around 50 components. I will be loaded here. So after moving here, I'll be moving again, move the component from this rack to this machine. So I'll be moving this component from this rack to this machine. So in this machine, we are going to produce a component. Means, so we are going to machine this component. Okay. So what I am going to do, so it will be moved here. I'll be selecting this. So add load activity, I'll be selecting. So loaded component is this. I will build the component. So you'll be understand it later when you are going with this, but I will be giving some demo on this. You have to look on this. Okay. So add transform activity. So for this, initial is the wrong serial. Finish on this. So this is the second product. So in the machine, I'll be giving this as a raw material, and the finished one is created like this. So after creating this, I'll be making it as an unloading. So unloading, select here, and what we are going to unload, a finished component we are going to unload, right? So after we are unloading it, okay. So just I'll be giving that. Again, it will be for outzone. So we'll be providing outzone here. So from here, from the machinery, it will be add product flow. From machinery, add product flow from machinery to this outzone. So this is the simple thing. So I will be taking some raw material and store in the rack, and from the rack I will be transferred to the machine. Here I will be transferred from one product to another, and I will be transferred to here. So this is a process I will be adding here. From moving from this rack to machine, I'll be adding some humans also. So in the resource, so I'll be adding a mankind. So here the mankind will be added. So I'll be add a man who is going to work here. So I'll be add a man, and this resource I'll be assigned to him. Okay, so I'll be assigned to him. So he'll be added as the source person to doing this one. So this is the thing I'm going to do. See here, I'll be just giving an input of a raw material transfer to the rack. From the rack, this human take the component from here to the machine. Here, the machine will be machined it and send it to the shop. So this is the thing I'll be doing it. And see here, I'll be simulate this process. See here, from this, it will be moved here. See here, that man came and take the component and position inside the machinery, and it will be manufactured and sent out to the output area, right? So this will be happen there, and again he'll be come again for a second component and pick the second component and take it back to them here. So in this process, see here, I'll be selecting this human. So what is the time taken for them to move, right? So we'll be calculating everything here. So what is the time taken by them, and what is the necessity for him? I will be consider it. And for this rack, how many component it will be? So total so far 18 component is stored inside, and this it will be take some 5 system will be there, and it will be carried away like this. So how many components it will be stored here? And in this machinery, so how many components it will be produced? So far 1 will be loaded initially and 2 will be sent out. So once the 2 will be sent out, another 1 will be loaded here. So another 1 will be loaded, and then another 1 will be processed. So like this, we will be giving an input, and we will be processing everything, and it will be sent out like this. So we will be creating a simple automations here. In this, if any optimization is needed, for example, see here, I will stop here. So in this machinery, I am going to edit. See here, for each operation in this machinery, what is the initial delay? So 0 delay. What is the load time? It will be take 5 seconds to load a component. Okay. So we'll be know that 5 seconds for loading a component. And what is the product? This is the product. We are going to produce this component to this. So what is the time taken for production, right? So transform, what is the time taken? 10 seconds they will be taking. So we can alter the time. So what is the time taken? We can alter everything. So once we have altered each and every process and will be given an input, means the timing will be varied based on the timing input. We'll be suggesting that it will be a sustainable thing. That means you can produce a better results, accurate dimensions will be produced. So we can get a good output will be getting, right? So this is the thing we are going to follow in this digital meeting. So we will be creating a virtual plant, working everything and find out what is the quantity needed. And based on this, we will be providing all the information and we will be getting it. Right. So so far I'll be explaining what is the sustainable production and what are all the advantages of moving all these things in your future career as engineers in the industries. What the industries needed from us in this field. So I'll be hope about this. If you have any doubts, you can. Thank you. If you have any doubts on this, you can unmute yourself and ask.
Dear students, if you have any doubt, please we just ask him, sir. Kumaravel, sir. Yes, students, if you have any doubt, kindly post in the chat box.
Yeah, you can post it on the chat box also. In Google Meet, there is a chat option is there. You can post it there so that I will be read it and give that what is the needed for you.
Okay, I think not even a single student is having any doubts, sir.
Another one thing, students. So actually, you are going to start your career as an engineer. So you will be having a thought in your mind. That means you are going to shape this world. That means as an engineer, we are going to shape everything. So you will be have in your mind that the futuristic thinking will be have in your mind. That's the main thing. As an engineer, you all should possess, right? So just don't think of this. What's the 12th standard students will be read a book, memorize everything, and write everything. That's not the thing. You have to think. That means you will be having a creative thinking. How creative you are, you will be having a better future. If I am explaining all this, you have to think on it. So how it will be working. In that, if you are thinking means you will be having a lot of doubts in it. So that I will be asking some of the questions. So in your future also, you have to think beyond the subjects. You'll be think creatively and try to implement with the design. Then only you can produce the component. Thank you all. Thank you, sir. Thank you for giving me an opportunity, sir.
Thank you, sir. Good afternoon, everyone. On behalf of the Department of Mechanical Engineering, I extend my artful gratitude to our esteemed chief guest, Mr. P. Kumaravel, Senior Design Manager, TANCAM, for delivering an insightful and inspiring session on design for sustainability, bridging theoretical concepts with real-world application. Your valuable expertise, practical industry perspectives, and thought-provoking ideas have greatly enriched our understanding of sustainable engineering practices and the significance in today's world. I sincerely thank our management, principal, head of the department, faculty members, and organizing committee for the constant support and guidance in making this event a success. I also extend my appreciation to all the participants and students for the enthusiastic presence and active interaction throughout the session. Once again, thank you, Mr. Kumaravel, sir, for sharing your knowledge and experience with us. We wish to continued success in all your future endeavors. Thank you all. Have a wonderful day. Thank you, sir.
Thank you, sir.
Dear students, I have posted the feedback session in your chat box. Please, all of you, give your valuable feedback. Dear students, all of you, can you hear my voice?
Yes, sir.
Yes, sir.
Please post the feedback session in the chat box. So all of you give your valuable feedback. Thank you.